So these are going to be your notes for two types of functions. We have the only two we really haven't done derivatives and integrals for are transcendental functions. And especially with transcendental, we're talking about e and ln x. And so e is an exponential function. And just like any other exponential function, if we're just talking about regular e to the x, you can always think about graphing it with a horizontal asymptote at the x-axis, because no matter what, when you raise this, no matter what power you raise this to, it's never going to get to zero, as long as we're talking about just regular e to the x. So exponential increase, we'll talk about exponents in class a little bit. We have that exponential increase. So this 0.01 is always a coordinate you can start with. And then you can do your regular graph shifting just like any other function. And the inverse of e to the x is natural log of x, sometimes called ln x. And so when you take the inverse, this is 0, 1, this becomes 1, 0. Everything reflects. And now we have a vertical asymptote at x equals 0, just like there was a horizontal asymptote y equals 0. So for ln x, the basic graph always has to be positive. So x always has to be positive, but the y can be positive or negative. Up here, at e to the x, y is always positive. So basic relationships, there are other exponential functions, other logarithms you might have done in other classes, but we're only going to focus on these two. And so you have a couple properties for derivatives, and we'll break this up into parts, but for this right now, it may include more than what you need for the first assignment. So there's a couple properties here. Derivative of natural log of x. So right, just like any other derivative, the derivative of the natural log of x is 1 over x. And that's it. And it's just it's a property, and then there's a chain rule that goes with it. The derivative of natural log of u is 1 over u times u prime. And oftentimes we just write this as u prime over u, and that's how you'll learn it. It's just saying u prime over u. And actually, so it's actually a pretty easy formula. So the derivative of what's inside the natural log over the actual what's inside the natural log. And then we will eventually integrate this as well, but those are the two main properties, and there'll be some examples we'll do on that. A few things you may or may not remember about log properties. The natural log of 1 is 0. That's because e to the 0 is 1. The natural log of a product can be broken up into the two natural logs being separated. The natural log of something to a power, you can move the n out front. And the natural log of a quotient is the difference. So these two kind of go together. And so sometimes when you're doing derivatives or practicing with derivatives of natural log, you relearn the rules, because sometimes it will help to expand things so you don't have to do as much calculus when you're taking the derivative. So for this one, I'll show you how to split this up. Start out by using the difference rule. So we split up the fraction, and then I can split this up into natural log of 3 plus the natural log of x squared. I can split this one up into natural log of 7 minus natural log of y. And you might wonder why there's a minus there. Well, it was minus this whole quantity